everybody. Welcome. Oops, I should close this right here. Yeah, okay. Make that a little smaller. Okay, welcome everybody. Welcome on in. We're continuing our discussion about the math for meds portion of this class. Just more discussion about dosages and stuff like that. So let's see. What do I want to show you? So let me double check the audio's right over here. Yep. And that's good. Okay. So here's where we're at. If you go to Canvas, and I'm going to be showing you a lot, so like I will most of the time. So you probably want to at least have the visuals up for the YouTube stream. I know some of you like to listen in Zoom and then watch the YouTube stream. That's fine if you want to do it that way, whatever works for you. But you were not going to see the stuff I'm trying to show you visually on Zoom, right? So I'll show you through YouTube. Let's see. So I've got the new stuff up, just up a few minutes ago. So there's chapter 8, chapter 9, chapter 10, and chapter 11. And then just like before, there's a discussion at the end of chapter 11 where you can get in there and mention some stuff that you maybe we didn't have time to mention in class. We have 90 minutes, or at this point about 87 minutes left. And we got 4 chapters to get through. There's quite a bit of stuff. But just as last time, there's some good videos I found, seem to be pretty much right on target for what we're learning for this class. I wouldn't be surprised if the people who made some of these videos knew that this book existed, because it seems like some of the topics match exactly. Maybe not, but some of them, like literally chapter 8 is how to read a syringe, and then here's a video, how to read a syringe. So highly relevant videos to what we're talking about. I still encourage you to read the chapters, because there is really important information in here that doesn't necessarily get covered in the videos. But the videos seem highly relevant and highly, very much the kinds of stuff that we're talking about. It's just that the videos don't cover every single thing that it gets covered in the chapters. And even though the chapters are short, usually like 10 pages or so, there's lots of good examples in there so that you can see, different types of labels that you're going to have to be expected to read. It gives you a little bit of practice with getting comfortable with this kind of stuff. And then going from there, okay? So, what I will say is the homework assignments are not up yet, but that's the first thing I'm going to do after class. I got a little bit behind in my schedule today, and I didn't get the homework assignments, the new ones posted, but I literally have it on my list here written in my my notebook. That's like with a big star for myself. So right when I end class, that's what I'm going to see. And I'm going to put up the homework for chapters 8, 9, 10, and 11. So as soon as, if anyone sticks around in class and asks me questions, then I'll answer those questions. But as soon as the questions are done, I'm immediately going to put those 4 homework assignments up so you can get working on those, and then also get that discussion board. Obviously after you read the chapters and you've looked over the material, then you can do the discussion, and I'll grade that previous one that's now due. I'll get that one graded and get you your points that you need. Okay. What I saw was a large number of our class signed up for the homework. So it looks, I didn't really get a lot of emails about that being difficult, or, in fact, I did get a couple of emails, but that was from people who went through the bookstore. So it's kind of an extra step and just a little more complicated. But as far as I know, no one is still struggling to get that set up or figure out how to get the homework set up. It looks like a whole bunch of you, most of you, in fact, almost all of you got in there, got signed up, and then did a significant portion of the homework so that you're moving ahead with things. So that's good. I highly encourage you to not fall behind in this stuff. It's obviously important. And, from here on out for the rest of the semester, you don't really want to get behind. It's the kind of slow and steady. You want to be the tortoise, not the hare, right? You want to be staying current with the stuff we're doing and not letting it pile up, because even though these chapters are short, you are getting them 4 at a time. So, if something happens and then all of a sudden you don't get it till the next week, now you got 8 chapters you got to do. It's difficult. Oh, and one thing I wanted to mention, so for most of the semester, the homework, if you did it late, you still got half credit, but it does not appear, I cannot find any setting to do that in the Cengage homework. So the current homework that you're working on for the Math for Meds, it does not appear that it allows me to give you half credit for doing it late. So I will not be able to do that. So please make sure you're getting it done when you're supposed to. Otherwise, you kind of miss out on that homework, which isn't good because you need to know how to do this kind of stuff. But I have the due date set so that it's moving people along, and there's not this temptation to fall behind and then let the homework pile up. Okay, so let me change that setting so it'll be quieter. I think I'm really pleased with this book so far. I think it's doing a really good job. So whether you're using remember you have the ebook version when you're doing the homework over on the left, at least on my screen, it's on the left. I know it's a little different for you, a little bit different view for you, but there's that ebook option where you can open the ebook and then you can look in there. I feel like this book does a really good job of explanations. There's lots of examples in there. They highlight the stuff that you need to know, or I shouldn't say highlight, but they bold the stuff that's kind of important so it stands out. I'm actually really pleased with this book. I think it's a pretty good book for what we're trying to learn. So, either use the ebook, or I know in my other class, I don't remember hearing specifically in this class, maybe someone did and I forgot, but I know in my other class, I know 2 of my students rented the book for the semester on Amazon, and it was like $12 or something like that. I think it was this class last time where someone mentioned getting it from the lending library, which is the second floor of the LRC. All you have to do is have an ID so they know who you are, and then you show them proof that you're in the class. If they still have copies, you get one for the rest of the semester. It won't even cost you anything. So I know at least one student, I think it was in this class, mentioned doing that. And as far as that student knew, they still had the copies of the book. And then I haven't heard any of my other students. No one's reported that they're out or anything. So definitely helpful. Definitely helpful. There's lots of pictures and images, which are great. And again, the videos, like how to read a syringe, a great video, but there's more information in these chapters that I would encourage you to get comfortable with. Okay, with that, let's jump into it. I'm assuming there's no questions. I haven't been getting questions in this class. I have not been getting emails where students are saying, I can't sign up for the homework, or I'm totally confused on this homework problem, or anything like that. So, make sure you're reaching out if you're confused. Coming to office hours, emailing me, or, more specifically, messaging me through Canvas is preferable. So make sure you're doing that, right? If you've made it this far, you've really done the most, let's face it, the first part of the class with the algebra was pretty hard. And then, I would say the math is significantly harder. And then also, I would imagine if you're in this field, less interesting. So, if you've made it this far, you definitely want to try to get to the end so that you don't end up having to take this class again. Okay, so hypodermic syringe measurement. So this is basically about how to read a syringe. Now, some of this stuff sounds like it'd be real easy when you hear it, like how to read a syringe. That must be easy. But as you'll see, and this is another reason it's really important to be reading these chapters out of the book, is they give you lots of examples of labels and stuff like that that you're going to be reading that might look really similar. And, you can see them in the different contexts. So you're just getting more experience with looking at the different labels and seeing how they go from there. Let's see. Okay, so there's one student mentioning having issues with submitting the assignment. If you're concerned, feel free to ask me after class. If you want to, after class, if you hop into Zoom, I can look. I know a lot of times students are nervous that that their assignment has not been submitted, but pretty much every time I look, the points are always there, right? Because basically it's not that you have to submit the whole assignment, it's that each time you do a problem, that information is being submitted. So it's, if you sat down and and for anyone on Zoom who's not seeing the question, there's a comment about being able to submit the assignments. So if you're talking about the Math for Meds stuff, the new homework assignments that are the chapters we're talking about, I know students get kind of worried because they go, oh, I spent all this time on like chapter 4, but then I don't think it's submitted correctly. But almost always when we go look, like the work's there. And sometimes, because basically it's uploading every time you do a different problem. Every time you answer a problem or do anything, it's updating. So it's not like you'll lose 90 minutes or 2 hours worth of work or something like that, and then you don't get credit for it. But if you have any concerns, stick around after class, and I can just double check in there that it's giving me a grade for your assignments. Okay? Yeah, so that goes for everybody, obviously, if you're in a similar situation. Okay, so, some of these topics sound like they're real simple, but I'll tell you, as I read through these chapters, because I obviously have to, this is, like I say, this is my first time teaching this class, so I'm reading through these chapters, and I'm learning lots of new things where I go, oh, I could see how that's a little bit more complicated, and then seeing the way different syringes are set up, and you kind of, this is the kind of stuff that's going to become second nature to you as you're doing it as part of your career. But the first time you see it can be a little confusing, and you go, wait a minute, is this what it's supposed to be set up as? So really helpful. So there's a variety of hypodermic syringes used in clinical use, right? So you're going to have to be comfortable with recognizing the different syringes, knowing when the different syringes should be used, and then being able to use those. And there's, just because there's lots of different medicines, and as you'll see today, there's lots of different ways that you're going to have to, get the proper dose of a medicine. There's lots of syringes. There's little tiny syringes. There's big giant syringes. There's the normal syringes. You want to be comfortable with being able to look at those and immediately be able to tell how to use it. And, like I said, that'll come somewhat with experience, but it's also helpful, like in this class, where we're looking at it and specifically figuring out how to do these things. Let's see. So a couple of things. It's necessary. You're going to have to learn the differences as well as similarities of the syringes that are in use. And then regardless of the syringe's volume or capacity, so there's different capacity syringes depending on the type of medicine that's being administered. And we'll talk about that. How are you supposed to pick the right syringe? And, being that this is a math class, it all comes down to math, right? And just making logical, reasonable choices along the way. And it's saying that regardless of syringe's volume or capacity, all except specialized insulin syringes are calibrated in milliliters, right? So remember, we did that work with the metric system. Looks like many of you did very well dealing with the metric system. Well, we're putting it to use right here with the milliliters, right? So we'll be looking at those different syringes. There's different manufacturers, different ways to set them up. Here's what I'll say, because it's a thing that I see a lot of in mathematics, is a lot of students have gotten through their public education, their K-12 system, by memorizing everything. And certainly in your classes that are preparing you to be nursing or healthcare professionals, whatever that may entail for a specific career, there is going to be things that you have to memorize, and being able to memorize these things will be very helpful to you. But I would also say, like, most of what I read, and I would say really, like, especially today, but a lot of what I'm reading in these different chapters is also just about, like, paying attention and thinking, like, logically. So memorization is helpful up to a point. The problem is if you have things memorized but you don't have the understanding behind the memorization, then when you do mix something up, you're not going to catch it. Okay? So, I see this all the time in math class where students just think that a student is supposed to memorize everything. And yeah, there are things you have to memorize, but really you should be thinking about things. And that is, I would say, from some of the chapters from last time, but also this time, it's very clear. If you've got your head in the game and you're paying attention to what you're doing and you're thinking along the way, does this make sense? You're much more likely to catch a mistake or not make a mistake in the first place. So again, don't go through these chapters trying to memorize everything. Reason your way through it. When you're looking at a label, reason your way through it. When you're looking at a syringe measurement, reason your way through what you're looking at. And if you understand what you're doing, then you're not going to mess it up. Whereas a lot of times, like I say, when people just act from memory alone, without like doing that common sense check along the way, or does this seem like a reasonable thing that I'm doing? If you don't do that, mistakes are going to slip through. So let's get into it. The calibrations on different volume syringes differ from each other, requiring particular care in dosage measurement. So you're going to have to be careful, right? So let's see if I can blow this up a little. Yes, I can do it right here, right? Maybe like that. There we go. That should be good. Okay, so standard 3 milliliter syringe. So the most common used hypodermic syringe is the 3 milliliter size, and it's let's see, we got a picture. I think it's on the next page is the next one, but that's sort of the most common one that you're going to see, right? We've got other sizes on there, and they talk about the number of calibrations. So what you always want to look at, because there's different calibrations on different syringes, is you want to look at them and pay attention to the numbers that are there. And usually it's in milliliters, but we are going to look at examples today where your syringes use a different unit. And then that's like what I'm talking about. You got to have your head in the game to recognize like, oh, this is not the normal type of syringe that I'm used to. This is a little bit different. So you have to look at it. So we have, you want to make sure you understand those gradations. Now, what we're talking about really is, they call them decimal fractions in this book, but they're really talking about decimals. But you're going to see fractions, you're going to see decimals, and I know sometimes that throws people off, but that's kind of what I'm talking about, or part of what I'm talking about if you understand the basic concepts of fractions and decimals and you're keeping your head in the game, you're sort of not just going through the motions, but actively paying attention and thinking about what you're doing, you're less likely to make a mistake when you're trying to read these things. Okay, so let's see. So here's an example of a syringe. You can see, we can't quite see because the unit is kind of cut off, but you can imagine in real life if you could turn the syringe a little bit, that's going to say 3 milliliters down there, right? So this is a 3 milliliter syringe, and you can see the gradations that we have along the way, right? So you should always be paying attention to what are these gradations, and realize that this first one at the top, that counts as 0. Okay, the book talks about one of the common mistakes is people make this first gradation 1, but really you should be treating this first gradation as 0, right? And then because you can kind of see that's where the color changes. So it's this first tiny one, that's your 1. So you've got 1, 2, 3, 4, and then the big one is 5 because it's in this case it's gradated. So like we're not being told explicitly, but by looking at this, I can tell that each of those little marks is 1/10 of a milliliter, right? So how am I doing that? Because it's not always going to be the case. You're going to see where we look at syringes where the gradations are in different levels. So how do I know that each one of these lines is representing, maybe I should make this a little bigger since it's a picture. I'll probably have to be adjusting the size a lot here. I'm just looking at how that's showing up on screen. Let's see if that looks better. Yeah, that's a little easier to see. So see this very top one? There's really nothing above it, so that makes sense that would be our 0. And then we go 1. So between 0 and 1, right? So I'm looking at the 0 mark. I'm looking at the 1 mark. So between here and here, that represents 1 milliliter, right? Well, how many gradations are there? There are 10. So if it takes 10 of these gradations to go up by 1 milliliter, that would indicate to us through simple division that 1 divided by 10, each one of these is a tenth of a milliliter. So you can do that with either the fraction 1/10. You can see on this particular one they're using fractions, but some of the I believe some of the syringes we're going to look at also use decimals, if I remember correctly. So you want to be comfortable with both of those things. Well, in this case, if it's 10 of these gradations to get 1 milliliter, then each one is a tenth. So you can either write that as 1/10 as a fraction, or remember the tenths place is the one right behind the decimal. So 0.1, that's a tenth of a milliliter. 0.2, that's 2/10 of a milliliter, and so on, right? So you can see what these gradations are indicating. And then the ones with the lines that are a little bit longer, that's indicating a bigger jump, right? So they're just kind of helping you check. So this one's a half, and then you have this line that's even slightly longer that's 1. And then, so you don't have to count every gradation from the beginning. If you were supposed to give 2.2, right? You were supposed to fill this up to 2.2. Well, you could jump right to 2 right here, and then you would go 2/10 more. So this next line and then the next one, and that's where you would want to fill with the medication too. Okay, so you got to. That's the thing. Like in this case, not all the little gradations aren't labeled because a lot of times there's not room for that. So you have to figure out what the little ones what they represent. A lot of times they represent a tenth of a milliliter. We're going to see some cases where they represent like 2/10 of a milliliter, where they go like in evens. So you always look at this scale and ask yourself, okay, what am I looking at? Don't make assumptions about what those lines do because you go, oh yeah, well, I've used a syringe like this before and I know what it represents. These syringes come in many, many variations. So always sort of start from scratch to make sure you understand the one you're looking at and not assuming that it's like something you've seen already. Okay? Oh yeah, I'm going to have to be changing the size a lot in here. Let's see. Okay, with that said, we've got, this one was just practice, if I recall. So let's see if I move that down one more. Darn it, why does it keep doing that? I'm trying to move it 1, let go. Okay, there we go. Got it that time. So here in the book, we can see this is just trying to give us an example of reading what these levels are. So it's got the arrow right there. You'll have homework problems like this, right? So it's got the arrow and it's asking, well, what is that measurement? Well, okay, so it's less than 1 because we know we're not down to 1 yet. And we discussed that each of these gradations is a tenth of a milliliter. So that's 1/10, 2/10. So 2/10 of a milliliter, which would be written as 0.2 milliliters down here, right? So what about this one? Okay, well, it's past 1, so we know we've got 1 milliliter, and then we're going 1, 2, 3, 4 more, so 1.4 milliliters, right? And by that same reasoning, we can see this one. It's 1/10 short of being 2, so that would be 1.9 milliliters, all right? So once you have one syringe and you're looking at it and you understand the scale that you're looking at, then it's pretty easy to make these measurements. But like I say, you kind of have to be on guard for always making sure that you're looking at the scale correctly because they change. And then they say here, remember the first long calibration on all syringes is 0. So remember this one always starts with 0. They mention here that a common mistake is thinking that this one is 0.1 when that's really the 0 mark. That's just telling you where to begin, right? So be careful not to mistakenly count it as 0.1 because that's not the right way. Calibrations are read from the front or top ring. Do not become confused by the second or bottom ring or the raised middle section if it's a suction cup. Okay, so here we see a slightly different one. So when we were down here, this wasn't really filled yet, but we can see there's like the little stopper here that's kind of keeping. This is like a little, grommet's not the right word, but it's basically sealing the medication up in this portion. It's not leaking down to below where the plunger is, right? So One of the things the book mentions is don't use the bottom of the plunger as you're reading. You want where the medicine is. Well, the medicine is going to be in this part up here, right up to the black line on the top of this plunger piece right here. So if we're looking at this, notice this one's in fractions now, and we're looking at it. Okay, it looks like each of these is still a tenth. So in this case, we're going to have what? 1, 2, 3, 4, 5, 6, and then it looks like it goes right to that next line for 7. So 7/10 of a milliliter, or 0.7 milliliters, right? Whereas this one goes a little bit past the 1, getting us to 1.2 milliliters. Notice that in the answers, they're writing it with that normal convention that we talked about last time. We're not writing this as 0.7 milliliters. We're writing it as 0.7 milliliters. That way, we're less likely to have our work misinterpreted, or we incorrectly read our own writing, or whatever we have to do to get that done. And then you'll do problems like this. So we just saw problems where they give us like an arrow, or they show us one that has the medicine in it, and we have to figure out how much medicine's in here. You're also going to have ones where they tell you to draw the arrow in the correct place. So at 1.3, we'd go to 1 and then go 1, 2, 3 more. So it'd be like right in here is where it's not on the arrow right now, so I can't point, but you can see right where it would go to give us that right amount. Okay. Yeah, that's more of the same. 3 milliliter syringes. Yeah, more of the same. Okay, safety syringes. So a number of safety syringes have been developed in recent years to reduce the danger of accidental contaminated needle sticks. Obviously, that's bad. Nobody, patient or a healthcare person or anybody wants to get stuck with a used needle, right? So there's certain needles that kind of have a protection on them, and they are designed generally to be used with one hand. So you don't have to be using both hands to do it. So you can see in this case, the person is operating it with just one hand. So here you're kind of flicking this piece off, unfolding it so the cover comes off, right? And that cover is just it's not sharp like a brand new syringe, so much less likely that it would puncture your skin. And then this one has a different type of cover, but you can see both are manipulated with an index finger, allowing that to open and close. So you will, you're likely to run across these in the profession, and you'll just, when you use them, you're kind of going to have to play with them, and then you'll figure out how they work, and then you can make use of them. But just be aware there are safety syringes out there, so don't be confused when you run across that. There's also this type of safety syringe. It's called the vanish point, which basically once it has administered its medicine, the needle automatically retracts inside. And obviously if the needle is retracted inside of the syringe, then you're not likely to poke yourself, because look at this big round plastic piece right here. You're not going to puncture yourself with that. So obviously safety is really important in the healthcare industry. Sort of amazing that they can do the things that you all will be doing in the future, where you're able to be around sick people and still able to largely protect yourself and keep yourself safe in the process. So that's obviously important. Let me remember which one is this one. This is the Magellan safety needle. Let me remember what was special about this one. This one can be activated in 3 ways: by thumb, forefinger, or on a flat surface. Right, so it's just another example. So there appears to be a wide variety of these safety syringes. This one has a big fat cap on it, where some of the other ones had a, sort of a smaller cap, but still something that's not likely to puncture your skin. This one has a big blunt plastic cover on it. Okay, when very small dosages are required, they are measured in special tuberculin. I assume that's how that's pronounced. Correct me if I'm wrong. TB for short. 0.5 or 1 milliliter syringes calibrated in hundredths. So we were just looking at examples of syringes that were calibrated in tenths, right? 1/10 increments. This one is calibrated in hundredths. So that's a much, much smaller calibration, right? So you can kind of see this here. You can see, I don't know if you can really tell by looking at it, but this is a much smaller diameter syringe in the first place, right? It's very, very narrow. Kind of have a close-up picture here. But look at these. We've got 0.1, 0.2, 0.3, 0.4, 0.5 milliliters. So that's where I'm talking about. You got to look at this syringe and really figure out what that gradation is. You can't just sort of rely on quickly assuming what it is, because this says, okay, in this case, we go 10 gradations between 0, this top mark, and the 0.1 mark, right? Well, 0.1 is a tenth. So a tenth of a tenth is a hundredth. So in this case, you can see, if there's 10 gradations between 0 and 0.1, then that means that each gradation is 0.01, right? 100th. And you remember on your decimal places, the first decimal place after the decimal is your tenths. The one after that is your hundredths. So it takes a second, but then it's clear what we just talked about in the previous paragraph, that, I see how each of these is a 100th. So it's a much smaller scale. If the dosage that you're giving is very sensitive and you really have to give the exact right amount, well, then you're probably giving it at a syringe like this, where you can be very exact. You can really fine-tune and make sure that the patient is getting the exact right amount that they need. Not too big, not too little, the right amount, okay? So check for that kind of stuff, right? It would be easy if you're not paying attention or you don't have your glasses on or something like that. You might not recognize the decimals right there in front of these numbers, and they would look like 1, 2, 3, 4, 5. Well, in that case, you're gonna misdose, right? So you realize, 10 gradations to get me to 0.1. That must mean each one is 100th. Right? So then you're going to have some practice where you go through and you look at the TB syringes, and you have to, remember, you're looking at the top of the black part, right? So just, you can kind of see the white part in here is the medicine, and it stops at the top of the plunger there to what you need. So in this case, like, what would this one be? This would give us 0.2. So we're past 0.2. This little longer gradation right above the black plunger would be 0.25. So it looks like we go 0.27. So it looks like this gets us to 0.27 or 0.27 milliliters. See, that allows you to really fine tune what you're getting there. Okay, so then you see more examples there of problems you'll do. Okay, 5 and 10 milliliter syringes. So this is going the other direction. This is when you're going to have to put a lot into the patient, right? So the 3 milliliter, if the amount that you're putting into the patient is more than 3 milliliters, then you don't want to use the 3 milliliter syringe, because then you're going to have to give them 2 shots, right? You're going to have to stick them once and then stick them again to give them whatever amount. Or if you're doing this into the IV that's already in there, you're going to have to connect 2 times, whatever. So it's a little easier. You've got your 5 and 10 milliliter syringes, and they're labeled that way. And again, looking closely, we see 1, 2, 3, 4, 5. I don't know if you can really see on screen, but this down here says 5. You can start to see the M, and then the ML is going around the corner, right? But I think you can imagine what it would look like. Whereas this one over here is making it clear, well, when we get to the bottom, that's at 10 milliliters, right? So you would just sort of go around to see what that looks like. So those are going to be like larger diameter when you're putting a larger amount of stuff into the patient. Now, what we want to recognize here is that our gradations are, we looked at a syringe where the gradations were 1/10. We looked at a syringe where the gradations were 100th. Well, this is neither, right? Because they mentioned down here, each shorter calibration actually measures 0.2 milliliters. Well, how would you know that? How do you know that? By looking at the syringe, that each gradation is actually 0.2 milliliters. Well, it's the same way that I was describing earlier, right? If we go from here, which is 0, and we're going down to 1, well, how many divisions are there between 0 and 1? Well, there's 1, 2, 3, 4, and then the 5th one when we get to the end. So that's 5 gradations. So if we take, that would be 1 milliliter, right? We know that this 1 represents 5 milliliters because down here it says 5 milliliters. So that would be 1 milliliter. Well, if we take 1 milliliter and divide it by 5, we get a fifth of a milliliter, or 0.2 milliliters, right? You just carry out the division. So that tells us that each gradation is 0.2. So see how if you weren't, I know how it is. People at the end of a long shift, you get tired. You're looking at the syringe and you go, oh, that's right, gradations are a tenth. Well, you want to be careful because here they're 2/10. So you always want to look. Like, that's what I'm saying. Always sort of take in the whole syringe and look carefully to make sure that you're considering all the pieces. Okay. And if there's any questions about the math here, feel free to ask because you'll be doing this on the homework and stuff. So then they just do the normal thing they've been at, If we look on here, we've got like how much is this? So it goes past the 1 and it goes 1, 2, 3, 4 more. So that one should be 1.8 because if we've gone 4 past 1 and each gradation is 0.2, then that puts us at 1.8. And then you can also see if we go 1 more, that puts us at 2. So then if we go any further, that would be 2 milliliters. Makes sense. We're at 1.8 milliliters right here. Right? Let's see. I think we are comfortable with those. 20 milliliter and larger syringes. So they get real big, right? To the point where, not each gradation here is like 1 milliliter because the whole thing is a 20 milliliter, and you can see that each gradation is representing a change of 1. So not nearly as exact, right? You're sort of seeing the extremes. Here we can see that we're in 1 milliliter increments, but then on the tiny ones, the tuberculin, and is that what they call it, syringe? Those gradations were 1/100th, so really, really tiny. So always kind of got to pay attention to that. Oh, let's see. So we should be good on those. Okay, and then that gets us to the end of that chapter. So that's chapter 8, and then, there's also a video there in Canvas so that you can watch how they do that. All right, parenteral medication labels and dosage calculation. So this is chapter 9, moving into chapter 9 now. So where's the picture? It must be on the next page. Parenteral medications are administered by injection, with intravenous, intramuscular, and subcutaneous being the most frequently used routes. The labels of oral and parenteral solutions are very similar, but the size of the average parenteral dosage label is much smaller. Intramuscular solutions are manufactured so that the average adult dosage will be contained in a volume of between 0.5 milliliters and 3 milliliters, with subcutaneous injections being smaller and seldom exceedingly 1 milliliter. And then here they kind of let you know, excessively large or small volumes would need to be questions and calculations rechecked. In other words, if something doesn't seem right, if you're getting ready to getting ready to do an injection and you're like, this is weird, this seems like it's too much medicine for what's going on, then stop and figure out what's going on. Is it a weird situation, or is it maybe that a calculation was done incorrectly, or maybe you're misinterpreting the gradations on that particular syringe so that you're actually reading the wrong amount. Okay. Volumes larger than 3 milliliters are difficult for a single IM injection site to absorb, and the 0.5 to 3 milliliter volume can be used as a guideline for accuracy of calculations in intramuscular and subcutaneous dosage. So intravenous medication administration is usually a 2-step procedure. The dosage is prepared first, then may be further diluted in IV fluids before administration. So we're going to see an example like that. In this chapter, we will be concerned only with the first step of IV drug preparation, which is accurate measurement of the prescribed dosage. There's a problem coming up where, basically you have to dilute it, and then you have to dilute it again right before you use it. So we'll get into that kind of stuff when we get to it. So reading metric SI solution labels. Okay, so we're looking at this kind of stuff. Ampules, vials, and pre-filled cartridges. So I think we talk about the pre-filled cartridges, I think, in the insulin chapter. And really, all these all kind of come up in the insulin chapter as well. Let me see if I can resize this just a little. There we go. So I'll show you the picture in just a minute. Refer to the Vistaril label down below. The immediate difference you will notice between this and oral solution labels is its size. Ampules and vials are small. So if the container's small, the label's going to be small. Very hard to read, which requires that you read with particular care. So be careful, read carefully. The information, however, is similar to oral labels. Vistaril is the, remember we talked about last time, the oral labels. Vistaril is the trade name of the drug. Hydroxyzine hydrochloride is the generic name. The dosage strength is 50 milligrams per milliliter. So we can see on here, they've got that 50 milligrams per milliliter. So you know that each milliliter in there is containing 50 milligrams of the drug. Okay, the total vial contents are generally on here. So that's like right here. Oh, wait. Where am I? Yeah. So they've got 10 milliliters. So that's telling you the total amount. So how much is in the whole vial. Right, and then it just kind of tells you, well, if there's 50 milligrams per milliliter, then if you're told to give a 50 milligram dose, that means you're going to measure out 1 milliliter, right? That makes sense. That's right in line with what they showed us here. What if you're told to give a 25 milligrams? Well, then you're going to want to use half a milliliter. So we've just got some basic division and multiplication here to figure out these dosages. What if you want 100 milligrams? Well, if it's 50 milligrams per milliliter and you want 100 milligrams, well, then you need to give out 2 milliliters, right? And then here's where it gets, some people get a little confused because it's not just multiplying or dividing by 2. What if we want a 75 milligram dose? Well, if you think about that, that's 50% more than just the typical dose. So we want an extra half dose. So if you can do this by just using your basic fraction multiplication. If you take 50 and you multiply it by 3 halves, which is 1.5, right? 3 over 2, you're going to end up with 1.5 milliliters that you're supposed to get. Okay, so pretty similar to the other labels that we were reading. The information's all there. You just gotta find it. Right, so like same thing with this one, Robinol. So you go through, and where is it on here? Right here. So they've got 0.2 milligrams per milliliter. So now you know for each milliliter you pull out of here, it's 0.2 milligrams. So if you're only supposed to give 0.1 milligram, well, then you should only give half a milliliter, right? So it's just those basic conversions that you were using before are telling you how to either scale your dosage up or scale your dosage down in order to make that work for what you're working on, okay? So you'll do some problems like that. Right. Let's see, which one should we, yeah, let's look at this one. Okay, so like for this one, we see the label, and we see that it's 40 milligrams per 10 milliliters or 4 milligrams per milliliter. So sometimes they give you 2 different ways of thinking about it. What it looks like from the book is it looks like sometimes they give it to you in this 4 milligram per milliliter, but if there's a real common dosage this is given as, they'll tell you that conversion as well just to make it simple. So if Ativan is regularly given as 40 milligrams, then they might just tell you 40 milligrams per 10 milliliters rather than just automatically using the simplest fractional form, right? Right. So let's say you want, what if 8 milligrams were ordered? How many milliliters would this be? Well, um, if there's 4 milligrams per milliliter and you're supposed to give 8 milligrams, then you want 2 milliliters, right? So you want to give basically 2 milliliters would give you 4 milligrams per milliliter. So you have 2 of them, so it gets you your 8. Right? What if it was 6? Again, this is one of those ones that isn't just doubling or halving. It can throw people off a little bit. Well, if you think about it, we get 4 milligrams per milliliter. So that means in half a milliliter, you have 2 milligrams, right? So if we're trying to get 6, if 6 milligrams were ordered, how many milliliters would this be? Well, you would get 4 from the first milliliter, and then you need 2 more. You'd get the other 2 from the half milliliter. So again, just multiplying out your basic conversions is gonna get you what you need. Okay, then we have our percent and ratio solution labels. Drugs labeled as percent solutions often express the dosage strength in metric measurements in addition to percentage strength. The lidocaine label below is a 2% solution is an example. Let's see. I think that's not the one I wanted to show you. I think there's another one we can talk about. See, let me catch my place. Sorry, I'm forgetting what I wanted to say at this point. I think that's not the one I wanted to do. Okay, so like for example, what is the ratio strength of this solution? So they're talking about the ratio. Well, we can kind of see the ratio right there, right? 1 to 1,000. So we see it's 1 to 1,000 or 1 milligram per milliliter. Right here, right? So we've got our strength right there. The volume, what volume is this contained in? So we've got our 1 milligram per milliliter, which is our, that's our, what is the metric dosage strength of the solution? 1 milligram per milliliter right there, right? And then we have, here it is. That's what I was looking for. We've got the this is a 1 milliliter ampule. Okay, so all that information they're asking for is on here. You just kind of have to hunt around, which makes sense. There's a lot of information given on these labels, so you really got to look because they like to put it in different spots for different labels, and you got to hunt around and really read it because some of them have like warnings on them. I don't think we've seen one yet where they have a warning, but like there will have maybe special instructions or special things to be careful about when using the medicine. Well, it doesn't do you any good to administer the medicine and then figure out that there's a warning label on there. You want to make sure you see that warning label before you administer the medicine, right? Solutions measured in international units. A number of drugs are measured in international units. The following labels will introduce you to several examples. So here's an example. So we've got what is the total volume of the vial? So total volume in this case should be 10 milliliters, right? We see it on there. We've got 10 milliliters. What is the dosage strength? Let's see. What is the dosage strength? So you've got 1,000 units per milliliter. So we can see that. They kind of put that in the bold so you can see exactly what you're looking at. If a volume of 1.5 milliliters is prepared, how many units will this be? Well, if it's 1,000 units per milliliter, then 1.5 milliliters should give you 1,500 units, right? Because it's 1.5 milliliters would give you 1.5 times 1,000, which is 1,500. How many? So you can see these questions are being asked from two directions. How many milliliters will you need to prepare a dosage of 5,500 units? Well, if each milliliter gives you 1,000 units, then you're going to need five milliliters would give you 5,000 units, but then you need another 500, so it's another half a milliliter. So 5 milliliters plus a half milliliters, or 5.5 milliliters, okay, should give you your 5,500 units, okay? Okay, we've got the next 4 labels will introduce you to the milli equivalent of dosages. Refer to the, let's see, they're just telling us which problem to go with. So this one's, I think, pretty straightforward as well. You're just reading whatever the conversion is right here, and then you're doing the same type of math. It's just in different units. So you're pretty much just, it's the same thing we've been looking at, right? Let's see. Right, and then that's the that's kind of the end there. So let's see for that one. Okay, chapter 10, reconstitution of powdered drugs. So from a chemistry standpoint, if you think about this from, chemistry class, what happens when you put a powder into a solution, right? Maybe when the drug is manufactured, maybe it's in powdered form. And so some things are going to be able to be put directly into liquid form and then shipped out that way and used that way. Well, sometimes that's a problem because depending on the chemistry of the thing that you're dealing with, once you put something into solution, depending on what you're talking about, chemical reactions can occur, right? Oxidation, things exposed to oxygen after a while, then other things can start to occur, which may not be what you want inside of your solution. So what we're talking about here is that sometimes the drug will be sent in powdered form because it's maybe just not stable when it's in the liquid form. It wants to react too much, right? Remember this from chemistry. Sometimes chemicals are really stable and what we call inert, where they don't really want to react with things. And then sometimes you have things that really want to react, right? Maybe they want to grab a free oxygen that's going by and they want to interact with that oxygen. And then all of a sudden, the chemical that was in your, that molecule of that chemical has now been transferred. It's become something else because it's had that interaction with the oxygen molecule. And then once too much of this happens, then your vial is no longer what you wanted it to be. It's now some different thing. So the bottom line is sometimes things are shipped in powdered form, and then you're going to have to sort of mix them up at the time of usage or sometimes within a day or two in order to make sure that they're fresh, basically, right? They can't make it at the manufacturing because if they mix it up at manufacturing, it could be days or weeks before it gets to you, and sometimes then the chemical in there will already have interacted and gone bad. So we don't want that. Right, it says here some drugs are shipped in powdered form because they retain their potency only a short time in solution. So you want to kind of not mess around with that. So let's start with the simplest type of reconstitution instructions. For a single strength solution, examine the label below for solumedrol, 500 milligrams. And keep in mind, reconstitution directions on vial labels may be small and difficult to read, and extreme care in reading them is essential, right? Because you want to obviously do the right thing there. You don't want to make a mistake because you're reading it wrong. Let's see if I can make this slightly smaller. There we go. Okay, so let's there's a couple of different things that you have to look for when you're reconstituting from powder into solution form. Obviously, you need to get the mixture correctly. You need to know how much of solution you're mixing with the drug. Okay, so there's different, there's a couple of different things that can be on the sorry, lost my train of thought. So you have to make sure you're getting your ratios right, and then you have to recognize that, well, what are the different types of material that's being put in the solution? You have the drug, right? But also it's going to tell you on the label what it is you're supposed to mix the drug with. Is it supposed to be bacteriostatic water, or is it supposed to be something else? You have to make sure that you're mixing it with the right thing. Looks like I went staticky or blurry here. Let me change that. There we go. Okay, so you're looking for the what material you're going to mix the drug with, and then make sure you have the right amount. So we call this the diluent, I think is how you would pronounce that. So the type of diluent specified will be different for different drugs, and the volume of the diluent will vary. So another thing you need to keep in mind is that what they're generally telling you in the instructions for how to mix this is how much of the two things to mix together. But what you want to recognize is if they tell you to use 8 milliliters of bacteriostatic water for the injection, and then you mix the drug into it, you're going to end up with a little more than 8 milliliters of the final solution, because the powder itself takes up some volume. So it kind of makes sense. If you have 8 milliliters of volume and then you add something to it, even if it's small and seems insignificant like a powder, that powder still takes up some room, right? Even as it's absorbed by the water, it's still taking up a little bit of room in that space. So you likely will end up with a little bit more than 8 milliliters of solution at the end. Okay. Once the type, I'm going to read this just because I want to make sure I don't miss anything. Once the type of diluent is identified, the next step is to use a sterile syringe and aseptic technique to drop the 8 milliliter volume required, right? Inject it slowly into the vial above the medication level, because air bubbles can distort drug dosages. So make sure, it's like when you do a lot of things, you want to be careful about aerating the water, because it can change the chemical makeup of the water, right? But it also can change, if you have more stuff, more like air and gases dissolved in that mixture, then it can throw off some of the stuff you're trying to look at. If the diluent volume is large, as in this case, be aware the syringe plunger will be forced out to expel air to re-equalize the internal vial pressure as you inject. So that's going to be part of it, is making sure that, that plunger can move in and out as necessary to have the right amount of stuff in that plunger. And then very large volumes of diluent will have to be injected in divided amounts to keep the internal vial pressure equalized. When all the diluent has been injected, the vial is rotated and upended until all the medication has been dissolved. Do not shake unless directed to do so. So they're telling you specifically here, do not shake it. So it might seem like, well, wouldn't that kind of speed things up if I shake it? Well, again, this can add air bubbles to the medications, and that can be problematic, right? It's surprising how often when you do all sorts of stuff, a lot of times you don't want gases dissolved in what you're doing. It's true in medication. It's oftentimes true in cooking or brewing things. You don't want gases to be there that aren't supposed to be there, because then what happens is those gases can come out of the solution at some point, and then they can be problematic, or they can react with the drug itself, which you also don't want. Okay. After reconstitution, locate the information that relates the length of time the reconstituted solution may be stored and how it must be stored. So I have to figure out which one it is when we take a look. You have basically some of them will say, this can be stored for 24 hours, or if refrigerated, then it can last 48 to 72 hours, right? So it depends on the storing procedure where you are. If it's going in a little refrigerator, then it's going to last longer than if it's just being left on the shelf. So obviously it's important if some of this, if it has a date on it, we'll talk about these dates in a minute, the expiration date, and someone put it in the refrigerator, then you don't want to leave it on the counter because then it's going to warm up and it's not going to last as long as it's supposed to. So make sure you're paying attention to that. The next step is to print. So this comes up. This is a question they ask a lot, right? So in the homework, you'll be answering this question a lot. The next step is to print your initials on the label as the person who reconstituted the drug in case any questions subsequently arise concerning the preparation. So this is similar to what we talked about before with the, the medication administration record, the MAR. You could figure out, who gave this shot at this time on this day? Oh, it was, Maria or whatever. And then you go talk to Maria if you have any questions about it. Well, it's the same thing with this mixture. If you're the person who did the mixture and there's some left over, then you initial it so that way if anyone has any questions, they can come find you about it, right? And they can ask you at the source, okay? And then you add the expiration date and time to the label. So I'll highlight it here. This exp, they make a big deal out of that in the homework. You have to put the exp there, which makes sense. If there's just a date and time listed, then people could say, well, what is this time supposed to represent? But the exp is making it clear. We're talking about expiration. We're talking about after this point, you should not be using that. So that's what you're supposed to do. If you're the person mixing this up and then there's some left over and you're leaving it for a person who's going to come after you, you need to make sure it's very clear at which point they should not be using it anymore with the expiration date and time. And right? And then they say here, key point. The person who reconstitutes a drug is responsible for labeling it with the date and time of expiration with his or her initials. That way, if there's any question, it can be figured out, right? And then this is what I was telling you before. Reconstituted volumes do not always exactly equal the amount of diluent added because there's also medicine in there. If it's a powder, that powder is going to take up a little bit of room in the mixture. Okay. Right, and then they just ask some questions here. Let me zoom out a little bit so we can see the whole thing. Oops, that's the wrong direction. Did I zoom out too much? Maybe. We'll have to see. Okay, so how should the drug be stored? You're probably not going to be able to read this, but you can see there's a bunch of stuff here in orange. So you're going to want to read that, right? There's the other information, which you can kind of get the initial main part of the information. But reading through this orange gives lots of information. So let's see. How should this drug be stored before reconstitution? So it says for storage, it says right here, storage before reconstitution. So I don't know if you can kind of tilt your head, but see where my cursor is? You can kind of see right there. It says storage before, let me see if I can blow this up a little. Kind of hard going back and forth. I'm trying to show you stuff, but then it's too small to read. It says before reconstitution, storage before reconstitution. So what was the question? How should this drug be stored before reconstitution? So it says store at or below 86 degrees Fahrenheit, 36 degrees Celsius. So we see right here where my cursor is moving, you can see that direction. Okay. How is this drug administered? Okay, usual adult usage. They're telling you. Looks like there's so IM use for what? Intramuscular. And then, let's see. I think for this one there was IV as well. Oh, yeah, for IV use. So you have IV use right here. They talk about it. and then there's the IM use down here. So 2 different places. So depending on how you're supposed to administer this drug, you'll want to read that piece of information. Okay, so it's on there. How long will the solution retain its potency at room temperature after reconstitution? So let's see. There should be something about storage after reconstitution. So here we go. Storage after reconstitution. So it says right here. So that information's there. You just got to find it. It says, depending on diluent used for reconstitution, solutions may be stored from 2 to 8 hours at room temperature or from 24 to 72 hours under refrigeration. So this is where if you're leaving the information for the next person who's going to use it, you have to know, like, okay, am I storing this with refrigeration or not? And that's going to decide whether the thing lasts 2 to 8 hours or 24 to 72 hours. So let's remind ourselves, what did they ask? How long will it remain at room temperature? So at room temperature, it says that's going to be 2 to 8 hours. Okay. How long if refrigerated? Well, that's going to be 24 to 72. They tell us right here. Okay, 24 to 72 hours. What else will you print on the label? Well, you're going to be printing the expiration date, and you also need your label. Yeah, you need your initials. Oh, sorry, I skipped one. If you reconstitute this drug at 10:10 a.m. on October 3rd and it is refrigerated, what expiration time will you print on the label? So, and it is refrigerated, what expiration time? So, let's see, 24, what does it say? 24 to 72 hours. So 24 hours would be the next day. So that would be October 4th. And then 3 days later would be October 6th. So that's why they're saying you write the exp, and then October 4th, 10:10 a.m. to October 6th, 10:10 a.m. And they say you have to put the exp in there. Otherwise, you don't want that kind of mistake. Someone writes a date on there and says, oh, no, that's when I mixed it, not when I expired. If you write the EXP, then it's always clear you're talking about the expiration, right? So the information's in there. You just got to read that tiny little writing in order to get at it and make sense of it. I think most of these are pretty straightforward. It's just those same kind of like basic fractions and divisions that we were talking about for the previous section. Let's see if I remember if there's anything special to mention here. I don't think so. Reconstitution from package insert directions. So sometimes there's, you know how this is. You open the little box and there's the vial and there's a label on the vial with that really, really tiny writing. And sometimes there's also like a folded up piece of paper, like a pamphlet in there, a little tiny pamphlet that also has information. So you can get additional information by reading that and just making sure that everything makes sense. But I don't think there was anything weird here. See how they have a lot more room here on the insert to write things. And this was an example. Let's see, is this in a different section? I thought this was multiple use. Oh, yeah. Yeah, anyways, you can follow the directions. This is one where it looks like there's, maybe I'm mixing this up with a problem we're going to look at later. But notice how there's a lot more information here, so you want to make sure you understand all of what that means. And then notice down here there's that caution. Caution, rapid administration may result in convulsive seizures. That's obviously a good thing to read before you administer the drug, right? That would feel pretty lousy if you, so basically what they're saying is like here, they're saying administer slowly over 10 to 15 minutes. And when you look up here, they're actually saying too, for those little shots, it should be over a few minutes, right? Here it says for this version, administer slowly over 3 to 5 minutes. What would feel terrible is if you just gave the person the normal thing for a normal drug where you give them the shot, you push it in, all at once, you've given them the dose, and then now it says, oh, more rapid administration may result in convulsive seizures. And now you're like, uh-oh, what just happened, right? So some of these slow-moving drugs you'd want to put in the, in the intravenous in the bag or whatever, and then it sort of slowly comes out. Oh, here's the one I was thinking of. Reconstitution of multiple strength solutions. So just be aware, like on here, there's more than, they give you directions for more than one strength that you can make this. So depending on what it is that you need to reconstitute, you've got some choices over here, right? And then it tells you the amount of units that would be in that particularly diluted dose, okay? So it's this one's pretty straightforward. I don't think there was anything tricky about this. Just recognizing that, oh, I have choices about more than one way to reconstitute this thing, right? And you can figure out how you want to do that. Oh, a multiple strength solution requires that you add one additional piece of information to the label after reconstitution, the dosage strength that you just mixed. So if you have different choices in which way you just mixed it, well, then obviously you want to write that down for the next person or yourself later who's going to be looking at that medicine and wondering like, well, wait, which of these three ways was it done? You've written it on the thing, so there's a record of how it works, right? Of what's been done. And you can see here, it's kind of sideways, but there's a bunch of information in here. So one of the things they ask on here is what kind of diluent is specified. Well, you can see on here, where was it? It says they say sterile water. So you're supposed to use sterile water to dilute this thing. Okay, so they're specifying what kind of thing to dilute it with. Okay, we got a little bit of time. We got one more chapter to go. This one has a few videos. I think there's 3 videos that I posted for this section that are all relevant, but this is sort of a highly relevant section, which is measuring insulin dosages. So diabetes is one of the fastest growing health problems in both the United States and Canada, which means you're obviously, as a healthcare provider, you're going to be dealing with that a lot. If it's the fastest growing or one of the fastest growing health problems, you're going to see it a lot, right? You're going to see it more and more. So that's why it kind of gets its own section, because it's such a big area. And things can be done slightly differently with it. So there's the 3 different videos I posted, which are helpful, but I didn't get a chance to watch all 3 of them all the way through. So I'm guessing there's still information in the book that you wouldn't get from the videos. Right. So types of insulin. So it used to be that there was just sort of one type of insulin from animal sources. Today there's a bunch, basically using DNA. But the thing you want to realize is there's different types of insulin. So depending on what you're trying to do, there's fast-acting insulin, and then there's like medium, I think they call it intermediate. Yeah, intermediate acting, which means it's kind of not short but not long. And then they have like the long-acting insulin, right? So that's part of it. And then you can see a lot of times, they try to be clever with the names of things. Like this is insulin, and you'll notice that the names, a lot of these names end with lin. Humulin, Novolin, right? So they're using the insulin part of the word insulin in the name to kind of remind you, oh, hey, Humulin is about insulin. And then you can kind of make that connection. It's just helpful, right? Novolin, that's one. Or is that the one I just said? Anyways, there's regular insulin is a clear solution, and it is fast acting, while so there's 2 different versions here. There's the Novolin R and there's the Novolin N, right? R is the regular and is clear and is fast acting. N is cloudy, classified as intermediate acting, and has a slower start but longer action. Now this is important because you're supposed to time these injections with the person's eating. And if you don't do that, if you either wait too long for the person to eat or your timing is not right, then the insulin's not going to be able to do what it was intended to do. So you want to be careful about that. You also get combinations of insulin. So there will be times where you are going to be administering an injection which is part fast-acting insulin and part slow-acting insulin, or part intermediate-acting insulin. And so there's a mixture. So you'll see like 70-30 or 50-50 mixes depending on what is prescribed, right? Depending on what's directed. Another type of DNA preparation is the analogs, which are chemically altered DNA. Depending on their structure, the analogs offer an extremely rapid action or a longer, more balanced blood control. So it just depends on what you're trying to do with these things. In this case, the log, again, they use that word log, analog, novolog. So they're using the word log to like remind you this is an analog, right? So you know, humalog, so that you can remember what it is that's actually being administered, right? Make it a little easier for you. Insulin vial and insulin injection pen label identification. So, some of the labels, some labels included are insulin pen preparations, that is pre-filled self-injection syringes that contain multiple doses of insulin. So they're like all ready to go, which kind of makes sense. If you have millions and millions of people taking insulin every single day in the country, you want it to be as easy as possible. So it makes sense they have these pens that are basically all ready to go and ready to use if the patient needs that particular dose, right? They talk about, I guess, highly advertised these insulin pens. Right. Pen insulins do not require refrigeration, which is helpful, right? Any complications you need for a medication make it harder. That was one of the, that's a concern with the, with any type of medication. But we saw that early on with, very early on with the coronavirus type stuff is, does this stuff have to be refrigerated? And if it has to be refrigerated, that gets it harder to get certain places, right? It's going to take more expense to transport it. That makes it hard to get in less developed countries that are maybe in dry regions, harder to get medications there then, right? Because it's just more things can go wrong, and then the stuff heats up, and then it's not good anymore. So you want to be careful about that. And then under no circumstances are insulin pens to be used for anyone other than the patient they are ordered for. So just make sure you're only using that exclusive with a single patient, and the patient specifically, not just a single patient, but specifically the one who is the intended patient, right? Because, and you can get more than one dose out of one, but obviously you don't want to inject somebody with one dose and then inject someone else with that same dose, because that needle wasn't clean for the second person. So obviously that's not good. So on these pens, you're getting, just like with a lot of the stuff, small labels. Now, in this case, they're not trying to fit quite as much on there, it looks like, but you're just going to have to read it and identify the stuff, right? So be able to read the thing, identify the names and the dosage and the units and all that kind of stuff. Let's see, I'm kind of running out of time. I want to make sure I get through stuff. But you can see here's an example on the label where we've got 70-30. So it's telling you, it says 70% human insulin isophane suspension, 30% human insulin injection, rDNA origin. So it's telling you what the mixture of this particular insulin is. So whatever's prescribed, you can go, oh, yep, here's the right thing, right? So all that same information, you've got 10 milliliters for the whole package. You've got 100 units per milliliter. It's telling you all that kind of information. It's telling you the manufacturer. And then over here, we've got some instructions. Refrigerate, do not freeze, shake carefully. Then it says important, see accompanying literature. They want to make sure you've read everything. So lots of information in these labels that we need to look at. But it's, pretty straightforward once you see it. So for instance, what exactly does the 50-50 identify? You can look on here, 50-50, and then right down here they tell you 50% insulin lisprotamine suspension, 50% insulin lispro injection rDNA origin. So you're seeing exactly what the two mixtures are, right? So there's not a huge mystery there. See, I thought there was a few more details we needed to look at. Yeah. Insulin syringes. So let's see. What was it we wanted to say here? Insulin is administered using special insulin syringes calibrated in units. In diameter, these are quite similar to the smaller TB syringes. So remember those little small syringes we talked about where the each gradation was really, really tiny. It was like a 1/100th of a milliliter. So these are small like that, right? Insulin syringes are used only for insulin administration, and they are available in the 100 unit, 500 unit, and 30 unit size. Oh, right. That's right. That's one of the things you're going to have to start deciding, like when you do the mixing, is which is the right size syringe that you need to use. Now, it's pretty straightforward. You use the smallest one that's big enough to hold the solution. So if you're injecting someone with 20 milliliters, then you don't go for the 100 milliliter syringe, right? So it has to be big enough to hold all the solution, but you don't want to go any bigger than you need to, right? There's a example coming up where we look at that. And they say sometimes you have to rotate insulin syringes side to side in order to locate the calibration that you need. So they're just, because you can see, like, it's hard to see everything at once. Like here, if we look right here, we're just seeing numbers. We can't really see the gradation. And then over here, you kind of see in the gradation, but not the numbers. So you might have to move it a little bit in order to do that. Not always, but we'll take a look here. So the calibrations work the same. Yeah. Okay, that's just saying it's the same. So then they give you some examples where they're having you read what are the gradations here in this particular case. There was something else. Oh, right. So this is what I was looking for. So you can see that they have, in some cases, you're going to have two measurements on there. So you've got like this left side and this right side. Well, notice what they've done here. Well, you try to kind of wrap your brain around what's going on. Imagine if you had just the right side, then notice between 20 units and 30 units, there's only 5 divisions, meaning you only get the even numbered dosages. So 20, 22, 24, 26, 28, 30. Well, that's fine as long as you're supposed to give an evenly numbered dosage. Well, what if you need to give an odd numbered dosage, right? You don't really want to eyeball it. You want to be able to get it exactly right, right? So what they've done then on the right or on the left is they've given you the odd version. So odd numbers. So if you have to give 17, then you'd go to 15 and go one more because that gets you to your 17. And then you can see they go 19, 21, 23, 25. So it's consistent. So if you have an odd numbered dosage, you'd use the scale on the left. An even numbered dosage, you'd use the one on the right. You could just imagine if these were all on one scale, that would just be too cramped to really see what's going on. It'd be really easy to get confused and get mixed up and put the wrong dosage in there. So they're giving you both so that you can use both the even and the odd. Sometimes you're only given even, and you just have to work with that. But in this case, they're giving you both. So that's why that's written that way that it is. Let's see, that was that the last thing I was going to show you? Combining insulin dosages, right. So there's a whole procedure, and there's a video on this about combining when you have two types of insulin. So remember the fast-acting insulin and the normal-acting insulin, you're sometimes going to be required to mix those together and then give it to the patient. Well, you're going to have to decide what is the appropriate syringe to use for that. So they give you the example here. There's a whole procedure, and we're about to run out of time. So read through this. Definitely read through this, and then there's a video in Canvas that also walks you through how to do it. And they kind of give you two different examples of how to go through and do that. You want to make sure you're doing it right, because you have to give the right amount of what do they call it? Air. What do they say? It's like a term they use in here. Yeah, they call it replacement air. So you have to make sure that you're leaving enough room for the medicine to get injected in there, and then doing it in the right way, right? Is equally important as insulin type and dosage is the timing of insulin administration based on the onset of action, peak and duration, and relationship to dietary intake. There's a video talking about those things as well. Insulin is classified by action as rapid, short, intermediate, or long-acting. The rapid-acting insulins varies from 10 to 30 minutes. So there's different time frames for these different levels of how fast they act. But then some of these must be followed immediately by a meal, right? Failure to immediately ingest food would result in a rapidly lowered blood glucose level, an insulin reaction from hypoglycemia. So you got to make sure that you're pairing the food with the insulin in the right duration and all that kind of stuff to make sure that, there's no adverse side effects, okay? Intermediate acting. Oh, right, injection sites. So insulin is injected subcutaneously. As with other parenteral medications, the injection site must be rotated, keeping at least an inch away from each previously used site. So you don't keep going back to the same site every time. You want to give that spot a little bit of time to sort of, go back to normal, and then and then you're good. So you're supposed to kind of spread these out a little bit, is what they're saying, at least an inch away from the previous site. And here's what I was talking about, where you're going to have questions where they say, what size syringe should you be using, right? So there were 30, 50, and 100. So if you're putting together, you need 28 units of regular with 64 units of NPH. Well, that's giving you a total of 92 units. Well, then you better use the 100 unit syringe, right? Whereas down here, 13 and 27, that's only 40. Well, the 30 unit syringe isn't big enough, but the 50 unit syringe is, so you'd use the 50. Okay, so always using the smallest one that has the capacity that you need. So in other words, you want to be able to get the whole dose into the syringe at once, but you don't want to use an excessively large syringe when that's not what's really necessary. Okay, and there we go. We finished sort of right on time. So watch the videos that are posted in Canvas. Read through the chapters. I will have the homework up. Like I say, that's literally the next thing I'm going to do. I'll answer any questions or concerns that people have on the Zoom meeting. So if you want to hop over there and ask me any kind of questions, or if you need help with getting the homework set up, although as far as I can tell, no one's really having trouble with that. But as soon as I've answered everyone's questions, I'm going to go right in there and set up the homework. So, in 10 minutes, you should be able to start the homework if you wanted to, but certainly in a little bit. Not being able to submit the assignments. Okay, so anyone who wants to hop into the Zoom meeting and just double check that the assignments are being submitted correctly, because they usually are when people are telling me they're... one thing is, it's just like with all these platforms, a lot of times phones don't work. So a lot of times phones, these homework platforms just don't work. And sometimes with the iPad, they don't work. So keep that in mind. Otherwise, feel free to hop into Zoom, and I can try to work with you and figure out what's going on. So the 2 people that were having issues with that, talk to me in Zoom, and we'll figure out what's going on. Otherwise, I'm shutting down the YouTube stream, and pay attention to the homework, as it will be up in about 10 minutes. Make sure you watch the videos, do the discussion, read the chapters, and then we'll be all ready to go in a week to continue our discussion. Okay, thanks everybody.